Hello and welcome to Well Control for Drilling Intervention and Workover with questions and subjects closely aligned to IWCF on my channel. In previous snippet, we already discussed pump and slug and tripping outflow on dry pipe and the effect of bottom hole pressure reduction. So now we're going to address the issue of pulling outflow or tripping outflow on wet pipe and the effect of bottom hole pressure. Let's get started. This is our well schematic with a certain length L, 1000 feet of drill pipe being tripped out wet, meaning we pull out steel and the mud in it, right? Therefore, we need to work out the closed stand displacement of the drill pipe. The information given is here. You have the drill pipe capacity, casing capacity, mud weight, and the drill pipe metal displacement. You just sum up the drill pipe capacity and the drill pipe metal displacement, you get the closed stand displacement of drill pipe, which is 0.0252 barrel per foot. So when you trip out from wet, you always deal with closed stand displacement of the drill pipe. So you already got the displacement, you work out the volume. That's easy. You take 1000 feet times the displacement, you get 25.2 barrels. Now you need to work out the capacity in barrel per foot of the mud left behind between the casing versus the drill pipe. And remember, because you take the mud out inside the drill pipe, so you need to work out using the closed stand displacement. Therefore, you take the casing capacity, which is 0.1522, deduct the closed stand displacement of the drill pipe, which is 0.0252. Then you have 0.127 barrel per foot. You have the volume of the mud and steel out. You have the capacity of the mud left in barrel per foot here. You just take the volume divided by that displacement in barrel per foot. You take 25.2 divided by 0.127. You get 198.4 feet of mud dropped in the annulus. That's a lot of drop in there, all right? So you take that length of mud drop times the mud weight times 0.052, you get the hydrostatic pressure that you have just lost, okay, which is 113 psi. That's quite a lot too. You can plug in all of those figures above in this short and quick formula here. You take mud weight times 0.052 times the length of wet pipe times the closed end displacement of drill pipe, or divided by the casing capacity deducting the drill pipe closed stand displacement. That's very easy. Next, what happened when you pull out of all the BHA, all the drill collars wet, meaning you take out the steel of the drill collars and the mud inside it, all right? Simple, right? You have information given here. With now, they give you the metal displacement of the drill collar and the capacity of the drill collar and the BHA length. When we talk about tripping wet, you just deal with the closed end displacement. So you work out the closed end displacement of the drill collar by adding up the metal displacement and the capacity. You get 0.009 barrel per foot. You take that one, you times the length of the BHA that you have pulled out wet, you get 5.4 barrels, right? Then you work out the capacity in barrel per foot of the mud left in hole. But now you have nothing in hole, you just pull out everything, drill collars out. So it's just simply the casing capacity, which is 0.1522 barrel per foot. Take 5.4 barrels divided by 0.1522 barrel per foot, you get the height of the mud dropped. Okay, so it's 35.5 feet here. You take that one times the mud weight times the 0.052, you get the PSI, the hydrostatic pressure loss. Okay, so that's simple. You can plug in all those figures in these two formulas here, and you get the bottom hole pressure reduction. All right, so the information, the calculation, and everything are just straightforward. I hope you enjoy it. And in the next video, I'll address the issues when you're tripping out with the trip sheet, and we will differentiate between swap and taking a kick by being under balance. See you soon. Cheers.